I'm going to give you some tips for the post-lab assignment for Lab 7, the weak acid titration. In your first data table, you will have recorded the mass of KHP that you used for each trial and also your initial and final burette volumes for each trial. In this column, you're going to calculate the total NaOH that you used for each trial. That's going to be the difference between the initial and final burette volumes. So this is just going to be the difference between your initial and your final volume. In the next column, you're going to calculate the moles of KHP. Notice up here it says that KHP has a molar mass of 204.2 grams per mole. KHP is an abbreviation for a molecule. It is not potassium, hydrogen, phosphorus. To calculate the moles of KHP, you're just going to use the mass that you recorded for each trial, and then you're going to do a gram to mole conversion using 204.2 grams per mole. In this column, you'll be reporting or calculating the moles of NaOH used in each one of these trials. And you're going to get that by converting the moles of KHP into moles of NaOH. Anytime you do a multimole conversion, you always need to use a balanced chemical equation, and the equation that you're looking for is right here. KHP and NaOH react with each other in a 1-to-1 ratio, so that's a super easy conversion. Every 1 mole of KHP requires 1 mole of NaOH. So this is going to be a 1-to-1 conversion factor. Nice and easy. And then last but not least, you're going to calculate the molarity of NaOH. The molarity of anything, in this case NaOH, is going to be the moles of that substance, in this case moles of NaOH, divided by the volume in liters. The volume of the NaOH solution in this situation. The moles of NaOH are coming from this column right here, and the volume of NaOH is coming from this column right here. Now you do need to be a little bit careful because we need our volume to be in units of liters, and in this column you have reported the volume in units of milliliters. So you do need to do a milliliter to liter conversion, but that's going to give you this. Now in this box, in this spot, you're going to calculate your average NaOH molarity. Depending on whether you're doing the lab in person or online, you're going to have slightly different instructions for this. This one tells you to calculate your average NaOH molarity from your 3 titrations. So that means you'll add all 3 of them up and divide by 3. And you may have, depending on your instructions, it may tell you to calculate the molarity from your 2 best titrations. So the ones that looked the best to you in terms of how faint was the pink color, just the ones that you felt the best about. You're going to calculate your average for the 2 best. So again, you will follow the instructions that you have when you look at this lab. For you, it will either say 3 or it will say 2, and you're going to follow those directions. Now the next data table is very similar. This is for the second titration. You will have recorded initial and final burette volumes, and you will be calculating the total NaOH volume by taking the difference between the initial and the final. In the next column, you will be reporting the molarity of NaOH. And for that, you're just going to be using the average molarity. So whatever you calculated as your average molarity in problem 2, you're just going to write that number down in all 3 of these boxes. In this spot, you'll be calculating the moles of NaOH. And you'll do that by using the equation for molarity. Remember, molarity is moles divided by liters. We know the molarity, it's right here. We know the volume, it's right here. Now again, the volume is in milliliters, it needs to be in liters, but other than that, we know the molarity, we know the volume, and we can use that to calculate the moles of NaOH. You'll do that for all 3. Once you know the moles of NaOH, you're going to convert that into the moles of acid. A multimole conversion always requires a balanced equation, and the balanced equation for this step is right here. The moles of NaOH, and this is our acid. And again, they react in a 1-to-1 ratio, so that's a really simple unit conversion. A 1-to-1 ratio between the NaOH and the acid. Last but not least, you'll be calculating the molarity of the acid. That is calculating the molarity, that's going to be moles divided by liters. For the acid, here's the moles of acid, and here's the volume of acid over here. So you're just going to take this moles, divide by this volume. Again, watch out for your units, milliliters versus liters. And then in question number 4, it's going to ask you to calculate your average molarity. Same type of thing. You might be asked to calculate the molarity for your 2 best titrations. You might be asked to calculate the molarity from all 3 of the titrations. You need to read your instructions carefully and answer whatever question is given to you. So with that, you're either going to take all 3 or you're going to pick the best 2 and calculate the average.